So welcome for today's lesson. So today's lesson we are having interesting topic which is work, energy and power. So work, energy and power. So what is work? So what is work? So work, it is the product of force and distance. That is work. So the product of force and distance. So when you are applying the force and also you are moving at a certain distance, that is what we are calling what? A work. So force and also the distance, that is work. So the formula for work is equal to what? Force times what? Distance. So that is the only thing which we need to know about work. Now, the question is, this is an object, but if this is an object, but you applied a force, but your force at this distance, I would say 3 meters, the object to reach here. Now, you applied a force, I say, I assume 20, that is the force. So to calculate here, to calculate the work, we are saying the work is equal to force times what? Distance. So work. So our force here is what? We are applying what? 20 at a certain distance, which is 3. So which is 60 joules, and the work it is in 60 joules. Now, when you are doing work, there is a force which opposes that work. That is what we call it, the friction force, which opposes this work. They say if let's give an example, which is example of 10 Newton. You are pushing, you are doing work, but there was an opposition force, which is the friction opposing this force. The friction was going this side. Now they will ask you, find the work done by a friction force. So since this friction force was opposing this work, so what is the formula for work done due to friction? So we say work done due to friction, it is Fk, which is friction force, times what? D. So always go in this side. So we say 10 times the distance, which is 20. Now, since this is a friction force, we say negative. So the work it is what? It is what? So the work done, sorry, it is done by, so it's a meter, force times what? Distance. So it should be here, should be 3. Remember, the friction force times what? The distance. So the distance is 3. Yes, so we say negative 30 Newton. Right. Now, so those are simple questions in the exam about work, energy and power. They are simple and easy. So we just need to know that the work is equal to force times distance. Even you need to know the what? You need to know even the units. The distance should be what? In meters. So distance should be what? In meters. That is the one thing you should need to know. Even the force should be what? In Newton. Then the unit for work, which is what? Joules. There's nothing which we can say much about work. That is the only thing which you need to know. Yes, you just need to know that Distance should be what? In meters. Then force should be what? In newtons. That's so. That's the one thing which you need to know about weight. Now, that is the only thing which you need to know on weight. Now, the question which comes in, they will tell you find the net weight. Yes. So the net weight or weight net. They can say weight net or weight net. It's okay. It's the same thing. It's the same English. So the weight net, we just subtract here 60, or I can say we just add, because here the friction force is negative. So we just add the friction, and so weight net. So weight net is equal to the force applied. So force applied minus so which is weight. Okay, weight applied like this. We say weight applied. Weight applied giving weight done by what? By friction. That's what. But we just add, because the friction force is negative. So there we just do 60 minus what? 60 minus 30. So it's giving us the net weight is 30 joules. End question. So that is the only thing which we need to know. Yes, that is the only thing which we need to know. The weight is equal to force times distance. According to grade 10, grade 9, grade 11, 12, you are learning about what? About the weight. Now, you find in the book the general formula for weight. What is the general formula for weight? They will tell you the weight is equal to force cos theta g. This is the general formula for what? For weight. So you just need to know that this is the general formula for weight. Yes, that is the general formula for weight. The question is comes in, why should we say that weight, the general formula is for a force cos theta times, we say that weight is equal to force cos theta g? The reason is simple. Since you'll be moving this, so force, you are moving in this direction, right? So when you are moving this direction, right, here you are not doing anything, you are not at any angle. Since you are moving the same distance here, you are not in an angle. That's why I said the first object, when you start moving in, when you put f cos 0 degrees is equal to g, so it will give you what? It will give you force times what? Distance. At 0 degrees, right? Yes. So it will give you force times distance. And also, when they tell you that the friction force, why friction force becomes negative? Sometimes we just put that friction, it is negative. But why? What is the reason? It is the same formula here. Remember, this is the distance, right? The distance is going this side. Now the friction pulls this side. So the friction makes what? Makes 180 what? Degrees. So when it makes 180 degrees, here we will use what? Cos 180 degrees. So force cos 180 degrees times d. So here cos 180 is -1. So when you punch on the calculator cos 180, it is -1. So there, that's why we say negative force times d. So that is the formula for what? For work done. That is the general formula for work done, which is work is equal to F cos theta times d. That's all. That is all what you need to know on work. So sometimes they will give you questions like this. When they apply what? A force at a certain angle, which is theta, at a certain distance, like they say 4 meters. So don't worry, you just use the same formula. Weight is equal to force times distance. So 4F cos theta then G. That is the key formula. So where is the theta? If it's 30, you just replace here it's 30. So your weight is equal to force cos 30 degrees then G. That is the only thing which we need to do. Now, they say when you lift something up, you are in. Then this is the distance here. Then you tend to lift something up. Why do we say that you are not doing any work when you lift something? Because of the same formula. Because here it's making what? 90 degrees. Here it's making what? 90 degrees. So if you put work is equal to force times or force cos theta then G. Where we say G is what? Or where theta is 90. So which is force cos 90 degrees then G. That's why we say when you are lifting something, you are lifting up. We say you are not doing any work because of this formula. Because the formula is expressed by this formula, that is work. So when you look at here, force cos 90, which is 0. So here the work done is equal to 0 because here it's giving us 0. That is what we say when you are lifting something up, you are not moving, you are doing what? You are doing no work. That's why we say joules. I hope it's clear. So that is the only thing which you need to know about work. Yes, there is no because that is the only thing we need to know about work. Yes, you will see when we start answering questions. When you start answering questions, you enjoy questions on work. But another thing which you need to know on work, but it's the same thing. I have already explained. Where the distance should go in the same direction, the work done should be positive. But when some distance, so this is the force and the distance. So when the force and the distance should go in the same direction, then the work should be positive. And also when the force going this side and the distance going this side, the work should be what? The work should be negative work. Yes. Because the force is going this side and the work is going to negative. I've already explained this. Either one of them or either two, both of them, they are going this side. Yes, it will be positive. Then when this going, this will be positive. Then it should be negative. I've already explained using the example of what? Of friction force. So that is the one thing which we need to know. Yes, even using the angle. Now, so this is simple. Now let's talk about energy. So what is energy? So what is energy? What is energy? So what is energy? So energy is the ability to do what? To do work. That is the energy. So energy is the ability to do work. Yes. So we have two types of energy, which is what? Kinetic energy and potential what? Potential energy. That's all. So we start with kinetic energy. So kinetic energy. So what is kinetic energy? So what is kinetic energy? So this is the energy possessed by a body, an object which is in motion. So when the object is in motion, it's moving. The object is moving, it's in the motion. That is what we call it, kinetic energy. So it's an energy which is possessed by an object which is in motion. So energy possessed by an object which is in motion. That is what we call kinetic energy. So we say kinetic energy is equal to what? Half mv squared. That is the formula for kinetic energy. That's so. That is the only thing which you need to know on kinetic energy. I will not explain much because here kinetic energy you need to know half mv squared. M, this is mass. Mass should be in kg. Velocity should be meter per second. That is the only thing which I will just. That is the only thing we just need to know, because I can't, because there's no much there is. So this is simple. That is the only thing we need to know on kinetic energy. That's all. We just need to know the formula, because it's the energy which is possessed by an object which is in motion. You know that mass is in kg, meter per second. Always kinetic energy is what should be in joules. Yes, that's all. Let's go to the potential energy. So potential energy. Yes. So potential energy. What is potential energy? So this is the energy which is possessed by an object which is not in motion. So the stationary body or stationary object possess what we call potential energy. And sometimes when you look at here, this object, this is an object, this is a cliff. Or say this is a cliff, let's say a cliff. This is a cliff. So this is each and every object which is not in motion. It contains what? Potential energy. Because this object is not moving here. It's not moving. So that is, it contains what? Potential energy. And the formula for potential energy is equal to what? mgh. That is the formula for potential energy. That's all. That is the formula for potential energy. So which is mass of this should be in kg. Then gravity, which is, we know the gravity here, which is 9.8. Yes. Sometimes even height you need to know the height, which is the height of this cliff. That's all. So that is the only thing which you need to know on potential energy. Even kinetic energy, it is simple. You know, when you start answering questions, different questions, so that it will help you to enhance your understanding on kinetic and potential energy. Now, let's move on to the last thing which we'll consider today, which is the power. Yes. Power, it is the rate. It is a rate at which energy is done. That's all. So the rate which you are doing what? The work. So this rate at which energy is done or the work is done. So the energy which you are using so that the work is done, that is what we call power. Because when you say, me I have power, because they do more work, the energy at the rate at which energy is done. Yes, the first, the energy which they will do, the work which they will do in a short period of time. That is what we call power. It is the rate at which energy is done. Yes. So that is power. And the formula for power is equal to what? Work done over what? Time. That is the formula for power. Or even the energy over time. That is the formula for power. And power, we need to know that power measured in watts. That is the formula for power. Yes. Yes, so that is the things which you need to know on power, and power is measured on watts. Yes. And sometimes there is also the formula for power. So the power is same. So there is also the formula for power. Let me show you. So power also is equal to what? V times I, which is voltage times current. That is when you are dealing with electricity. Even power can be equal to, yes, force times the velocity. So force times velocity. That is the only thing which you need to know on power. They will just ask you to calculate the power when you have calculated the work. So just use this to move in time. So time should be in seconds. The work should be what? In joules. Even voltage, volts, even I, which is ampere. Yes. Force, you know that force is Newton. Then velocity, which is meter per second. So that is the one thing which you need to know on power. So today's lesson, we end here for today's lesson. So our next lesson, since we have done work, energy and power, our next lesson is momentum. Then we call it a semester. We start revising questions, examination questions. Yes.